We've been designing robotic products together now for several years. We discovered that the one thing that's really holding back the next generation of mobile robots in the consumer market is an affordable and powerful scanning LiDAR sensor. LiDAR sensors are crucial to the success of autonomous vehicles, like self-driving cars and smart drones. They use laser light to detect how far away surfaces are, in order to do things like avoid hazards and make maps in new environments. We saw that most scanners were priced in the several thousands of dollars, and oftentimes are the single most expensive item in a robot. Even the ones that were more affordable just didn't perform well enough and were frustrating to use. So we set out to make one ourselves. With Sweep, we created the world's first long-range scanner that's purpose-built for consumer applications. When we designed Sweep, we had three main goals: make it powerful, make it easy to use, and make it affordable. We wanted even the most novice users to get up and running quickly, but we still wanted to provide the depth of information that the more seasoned users would expect. We went through almost a dozen iterations over the last 2 years until we found the perfect balance of simplicity and capability.
We also developed a visualization application that allows for quick viewing of the data, with options like signal strength feedback that allows for a deep understanding of the information. We provided easy mounting holes and dual communication ports for easy mounting and integration. On aerial vehicles, Sweep can be used to avoid crashes in unpredictable environments. Remote control signal loss and first-time pilot errors can be dealt with gracefully. On ground robots, it can help avoid obstacles and map out environments. It will be especially useful for education programs like FIRST Robotics.
Beyond robotics, there are many opportunities for using Sweep in research and digital art. Projects like this interactive music composer show just how creative the uses for LiDAR can be. By providing tutorials and example applications, we want to make it easy to pick up your sensor and run with your imagination. We're developing ROS drivers and example applications for Arduino and Raspberry Pi, and also SDKs for all the major languages.
We're excited to see what you're going to be doing with Sweep. We've put together a great team and a line of our manufacturers. Now we need your help and Kickstarter to make this happen.
I am Clément Briand, the founder of We Are Projector, and here is Visio, the first handy photo projector.
Visio is an analog projector. It is mobile, modular, and compatible with every 35mm lenses. It is the smallest yet most powerful photo projector ever created. Visio is mobile, so instead of being fixed in a place, you can use it everywhere on everything. With Visio, the world becomes a real screen for your projections. It's a unique tool for photographers and visual artists who want to share their visions to the world. Analog pictures deliver high-quality projections far better than digital ones. Your old slides can relive, and your digital pictures can also be transferred on slides with a true photographic quality. Analog processes can also be used. By using glass-like months, you can instantly project messages, but also drawings and all pictures created by contact, like fingerprints. Visio is composed of different items screwed together: an LED lamp, several rings, lens hoods, closed-up lenses, a slide holder ring, and interchangeable mounts to adapt all your 35mm lenses. All these items already exist, except for the slide holder ring. We need your help to produce this ring. Once produced, we will be able to provide Visio as a kit to assemble or already mounted. It will be composed of perfectly compatible items with a 35mm mount of your choice to choose between 5 main brands.
Let's create a community together and spread photo projection around the world.
Drones crash all the time. Why? It could be the result of human error, weather conditions, or even motor failure. But no matter the reason, it's going to cost you time and it's going to cost you money. But don't worry, I've got a solution for you. Meet SafeAir, the best parachute system for your drone. Parazero's SafeAir is easy to install, and the system's weight barely impacts the drone's flight ability. The SafeAir system can detect critical failures and deploy autonomously and does not rely on the drone systems. The autonomous system allows a soft landing to protect the people and property below and the drone itself. In addition to all these benefits, using the SafeAir system may allow you to get extended operational approval from authorities as well as discounted insurance policies. And don't worry, you don't need to buy a new one every time. SafeAir, it just works.
One of the big issues with creating virtual reality content and 360-degree camera content is the time it takes from capturing to stitching and then distribution. That is where the Live Planet system wants to come in and make everything much more simple. This is a prototype camera right now. As you can see, the real version is actually going to be quite a little bit smaller and much more compact. It is an entire live virtual reality system, so you can see everything happening live around you, streamed either to a computer, through the cloud in a virtual reality headset. So how this works, there are 16 lenses with synchronized sensors sitting behind them. All of the processing and the encoding and the stitching itself is done in camera. There is an internal 512 gigabyte storage system that is used for recording video, or you can actually stream it live out to the cloud. Now what the cloud does is then take care of all of that distribution problem for you. So it sends it out to whatever platform you like. At launch, when it launches in the fourth quarter of 2016, you're going to be able to send it out to platforms like Facebook 360, YouTube 360, the Oculus Rift, the HTC Vive, and the Samsung Gear VR. And it's not going to be cheap, however. It is going to cost around $10,000 when it's released at the end of this year, although there is a pre-order system available and it's going to be around $5,000, definitely targeted towards newsmakers, documentary filmmakers, rather than the everyday consumer, but you get to see yourself and watch everything in live virtual reality.
Hey, I'm Ethan. I made a camera. Actually, I made a few of them. It's based on a classic field camera design. Folds up. It's got geared rack and pinion focusing on the front and back rails. Swings and tilts. You know, just like a regular camera, but more colorful. The bellows and focusing rails support a lens from about 90mm to about 300mm. I prefer a 150 to 210 normal lens. The camera's 3D printed. The bellows are handmade with a little help from a laser cutter, and the ground glass I grind by hand. Because the camera is 3D printed, you'll be able to choose a color for each one of 10 print groups. The camera is made of 12. The lens board and the film back necessarily need to be black. The others could be just about any color I can get filament for. For the 10 print groups, you can pick any available color. The rear frame, the front frame, the rear rails, the front rails, both frame carriers, the focusing pinions, the base plate, the swing arms, spindle carriers, and tripod mount, the screws, and the ground glass spring frame. You can also pick your bellows fabric. I call them Cameradactyl because I love cameras, dinosaurs, and all the realword.coms were taken. Cameradactyl! Ah! Currently, each camera takes over 130 printer hours to print. By supporting this project, you'll help me buy a bunch more 3D printers, which will help me produce the cameras at a more reasonable pace. Thanks very much for taking a look. I appreciate it.